right. Hello, everyone. Good afternoon, good evening, good morning. We have a nice international audience today. According to the information I've received, we have viewers all the way out in Japan, so I guess it's in the middle of the night for you. We have viewers also in North America, so it's morning there. Lucky us here in Europe, it is afternoon. Waiting for people to gradually join, but I'd like to warmly welcome everyone. This is now the fourth session in PrintoCent's webinar series 2021. And this particular webinar session is focused on the EU co-funded Decochrom project, in which we have been developing interactive printed graphics. And I'm sure that this term will raise a lot of questions. What is it? That is what we're here to tell you all about. Today's webinar, a practicality. First of all, my name is Jani-Mikael Kuusisto from Invisible. I have the honor of hosting this session. Invisible has been a member in PrintoCent since 2011, and we're very, very happy to share also some of our experiences in working with this commercialization community. Today's webinar is being recorded and will be made available then on YouTube. If you go on YouTube and you search PrintoCent, you will also find recordings from earlier webinar sessions. A few words about PrintoCent. As I said, this is a printed electronics, printed intelligence industry cluster, really looking at how to commercialize technologies emerging from academia and research into the markets, and working together to bring these new capabilities out into the world. Here is a list of our current industry cluster members. Of course, we collaborate more broadly, as you will see also in today's agenda. To learn more about PrintoCent, do visit printocent.net, the website, and we'll have contact details also at the end of this session. One way that PrintoCent works to bring new technologies out into the world is through these jointly funded projects. And we have had the great honor to be able to work with some projects that have been funded with the help of the European Commission, Horizon 2020 program being one such program. Today's session is really focused on one of these projects. I think it is a nice example of how members within the PrintoCent community work together and reached out to other universities and companies to put up a very exciting group of companies and universities around a shared topic. And in this case, that shared topic was printed electrochromic displays. Today's session looks at what has been achieved since the start of this project. The project kicked off early 2018, so it's now 3 years running, and it's good to get a view to what the project is all about, where are things in terms of these new functionalities for printed electrochromics. A starting premise for this project was, in fact, to also not only enhance the performance, technological performance of printed electrochromics, but also to introduce the technology to a wider community of designers. In our field of printed electronics, this has been a topic for many years. How do we get product designers working with our emerging technologies. And this project has been a very vital instrument for introducing printed electrochromics to the design community. I will begin by saying a few words on what is printed electrochromics. Then Jonna Häkkilä from University of Lapland will introduce the Decochrom project. We have Peter Macon, all the way from North Carolina, sharing some thoughts on industry needs for printed interactive graphics, challenging us to look at the market needs and possibilities for these color changing surfaces. Then Markus Lechtfeld from Aalborg University in Denmark will say a few words and show how this project has engaged the design community. Ashley Colley, also from the University of Lapland, will then share a few examples of the work done in Decochrom. And stay tuned. This time around, you, the audience, will not just be passively sitting there. This time, we'll want you to get involved. In addition to sending your questions to the speakers through the Q&A box, you see the Q&A box there? Please send your questions. Our speakers will answer them either in writing or then at the Q&A session at the end. But in addition to that, we will have a bit of a poll, a vote, in terms of the different concepts that Decochrom as a group has been working on, to get your opinions on which of these concepts should be explored further, for instance, in a form of a crowdfunding campaign. So beware, be ready to give your vote. In the end, we will have five-minute talks from some of the project partners that are in the project. There are many others, but in the interest of time, these were the 5. So Invisible, Surforma, We Productize, Fraunhofer, and VTT. All right, so to move along, very brief introduction to what is printed electrochromics. First of all, what is electrochromics? Where is electrochromics used today? Electrochromics today can be found in smart window applications. I know it's a long time since many of you have last sat in an airplane, but if you were in one of the Dreamliner Boeing airplanes, you will have seen these windows that no longer had the shade that you pull down, but rather there was a dimming button. You could increase the darkness of the window or transparency of the window. That is an electrochromic device. More likely, however, you've seen it in your car, in the rear view mirrors, side mirrors, and that is big business. A company, Gentex, has been out of Michigan, has been hugely successful in that as a business. So electrochromics products are out there. Functioning of electrochromics, the basics, it's a redox reaction process. And there is a flow of electrons from one species to the other, as they say, and redox oxidation. And what happens when the electrons flow is that there is a change in the coloration of the material or its transparency. The color can go from transparent to colored and vice versa, or it can go from one color to the other. It is all electrically driven, very low power consuming. And what happens in the world of printed electrochromics is we are taking these materials into printable form so that they can be applied also onto flexible substrates. So now we can expand the markets from these glass-based rigid applications of electrochromics to flexible-based devices for a range of different purposes. And the advantage of this is, as a display technology, is now we start to bring life to printed objects. And printing is all around us, from the laminates on our floors and tables to posters to wallpapers. printing is everywhere. We are not offering the high-end, high-resolution displays, but rather bringing life to the printed graphic. And the video on the top right here shows under a mobile microscope what a printed surface, still printed surface looks like when there is an electrochromic layer on top. These devices are thin, flexible, transparent. They're ultra low power. They can be powered in a myriad of different ways. And there's many exciting emerging powering techniques emerging from printed electronics, printable batteries, OPVs, wide range. They are durable. They can withstand quite wide temperature ranges. It offers many freedoms of design. No longer are you confined to a rectangular, rigid electronic display, but now you can shape it and mold it in different ways. And you can produce systems on film. So you can print the display in combination with other components that are printed or then bonded onto the film. And then you can integrate that into and onto various different substrates, high pressure laminates, different plastics. So that was a quick introduction to what is printed electrochromics, but enough of me and my spiel. It's time to get introduced to Decochrom. Has Jonna arrived? She was on her way and in a hurry to the university.
Yes.
Excellent, Jonna. So
all online.
Yes. So
Rovaniemi.
The stage is yours.
Okay, and let me share my screen. Okay. And I believe you have the, yes, so it seems that this is, technology is working fine, which is a pleasant surprise always. So thank you, Jani Mikael, for the introduction and for the also introducing the business context, what we are working on with this Decochrom project. So as mentioned before, this Decochrom project is EU-funded project for 4 years, and now we are just starting our final year. And you can see here, it's a huge consortium, 6.7 million euros in the process, delivering hopefully great results on every work package and all kinds of aspects of related to electrochromic display and productization. So as you can see here, there's multiple countries involved. So the coordination happening here over, at the University of Lapland, Faculty of Art and Design. So a little bit designy touch there. But then partners are really from chemistry industry, the display production, manufacturing, electronics, and different companies looking at the how to productize or what are the possibilities for product creation in the area of electrochromic displays. So here's the consortium when we were still able to meet face to face. So just about everybody, every person in the project was able to travel to Lapland just a year ago, just before the pandemic. And since that, we have been working on online mode, remote mode, and especially challenging, of course, for a project where there's a lot of laboratory work and workshops involved. But we have managed to do that greatly. So really, I'm proud of this gang, and it's really has been great to work with all these people. We just had a month 36 review meeting, so a little bit different group photo here. So all online now. So Decochrom project, what are the objectives? So basically, it's first of all to elevate the printed graphics products to the age of interactivity. So we live in the world of displays. There's posters and different kind of written or pictorial or graphical material all around us. But then how to really make this interactive? So this old printing industry, posters, these kind of wallpapers, also on all this could be interactive in the future. And secondly, there's the second objective is to empower the creative industries with the tools and material sets that enable these new designs with these electrochromic interactive graphics. So really, not just like working for developers or researchers, but really for the artists, for craftsmanship, and all these big creative industries also in the mass production scale. So this is really something unique here. And thirdly, the objective is to build aesthetically pleasing, practical human interfaces to smart consumer goods and smart consumer environments. And what we want to aim at is something like solutions like this. So these are the design visions in the beginning of the project. So really embedding multicolor electrochromic displays on the floors, the furniture, and creating these kind of calm interactive display indicators. Not just like the conventional displays that shine brightly on your face and disturb you, but this kind of calm, aesthetic, and smooth display and interactive graphics. Really, this project covers really the different phases of the production chain. So from developing the electrochromic inks to creating the displays, scaling up the production, and then creating concepts for new end products and prototyping them. And then, of course, this empowering, not just working for ourselves, but empowering the new industries, new actors to get involved. And it is a truly multidisciplinary project. So here you see some of the this kind of project process graphics. So how different parts of the process project fit together. And really these targets are this to develop next generation electrochromic displays. That means like more colors, better visibility, faster switching time, more durable products, and trying out different flexible and transparent materials. And what we work towards is really different kind of design prototypes in the area of architecture, fashion, furniture, decorations, household applications, and art. And then also creating these toolkits. And how this work is organized in the project. So we have work packages with different specialists working on their related areas. So first of all, developing these inks, searching for like different, really doing the chemistry in the search for different colors. Then making them to surfaces, these actual displays. So putting inks to the display through the process to create the really displays here invisible. And Jani Mikael's work much here. And then when we have these displays, of course, we need to then embed the electronics and the control electronics and everything else that is needed to run these displays and enable interactive applications. So that's the work package 3. So here, especially VTT's work much here. And then when these components are ready, then we go for design and creating prototypes and then piloting them with real users in the real use contexts. And all this is supported by sustainability assessments. And of course, the normal project stuff with the dissemination, exploitation, special interest groups, publications, and so on. And I think I end my presentation here, and Thank you. I hand over to the next person.
All right, thank you, Jonna. So if you stop sharing your screen, that was a nice introduction to how this project is structured and the main objectives. Given that the design is a very critical part of this project and introducing new technologies to market in general, we felt it was great to bring on board to this webinar someone who is truly experienced in working with new materials and integrating those into products that many of you will have also bought, played with. So Peter Macon from Charlotte, North Carolina. Good morning, Peter.
Good morning, Yanni. Let me share my screen. We here in the US, we are having ice and more ice. So, but in North Carolina, we have nothing but rain. So if you hear lumber being sawed and hammered in the background, it's because we're building arcs to save ourselves from the floods that we're having challenges with. First of all, thank you to Yanni and to the PrintoCent cluster. I have been on the periphery of this cluster group for a number of years. I have worked with Yanni in specific projects. I have worked with VTT and actually in a current active program. The idea of smart materials, smart electronics, and let's really talk about printed electronics is an incredible platform for future. And what I want to do this morning is to challenge you with just different forms, different ideas. What we do as a company, we work globally. We work primarily on consumer products. So generally speaking, we're anywhere from 12 to 36 months ahead of what you're apt to see in the store. This first slide just demonstrates how we like to look at materials and reimagine them. We participate in worldwide material libraries. We do a lot of archiving of materials ourselves. So our word is reimagining, and I think we can give you some perspectives here that you'll find fun. The idea of electrochromatics being printed is an astounding step forward. So the Decochrom project was talking about illustrating of posters or wallpaper, or gee, what about greeting cards, or what about very specific form factors that we'll talk about. We are designers, we are design engineers, and we work in these consumer clusters that you see, whether it be orthopedics or blunt trauma, footwear, helmetry, delivery drones, developing new chemistries with large chemical companies. And then what Yanni alluded to, we are the Nerf guys, so we get to play a lot as well. And in the next few slides, you'll see some illustrations of forms, and imagine how they can be enlivened with printed electronics. It's more than reimagining. It's bringing to life with real illumination strategies that take and almost add a third dimension to the product line. As I said, we have been involved with printed electronics for 7 years. Our overall time frame of company is 25 years plus. Because I now have a lot of gray hair, I like to say that I started my career when I was 5, just to just to give the illusion of youth. But again, we work globally. We have assets and globally. What you see here is our triangle. For us, it's about material expertise that prompts concept engineering and process experience. I chose this slide to simply, it was one of the better slides we had in showing light. Yes, it's electroluminescence, but the idea here is to enjoy light as it can be done in so many different ways in printing. And you all, part of the PrintoCent cluster, have brought this beyond the idea of concept into really being able to print and print in a manufacturing environment that now people like me are able to assign a cost and are able to really integrate it into product. This idea of manufacturing capacity is absolutely critical to application, and it has come far in the last 7 or 8 years from my experience. So these next images are simply to prompt enthusiasm and ideas around how product can be re-envisioned. Obviously, we work in the sports world and in the toy world. And now, because we can do printed surfaces, we can create transparencies. And then we can create lighting within those transparencies. We can create combinations of printed electronic technologies, as Yanni alluded to in his presentation. You can create different moods, and you can create different play patterns. And particularly in these times, mood and play pattern and being able to elevate it has been an adventure. Currently, color change has been all about what you see here, whether it be a thermochromatic or a hydrochromatic or a photochromatic. But as effective as they are, imagine this slide with light influence. Imagine the ability to look at an object, touch an object, and have a residual effect, and have as electrochromatics comes along and develops more color palette, a greater color palette, imagine what that could be. The image on the right is a play mat, and it was all about Twister trying to get from put limbs and feet, etc., on different spots. Well, imagine what that interactivity could be if we were using light. From a performance indicator, we've talked about, and Invisible has done a great job of talking about tags and indicators. What I'm questioning is how can we expand that with different form factors? So hence why I put some super soakers and some Nerf footballs in the mix. What would happen if we enliven these surfaces with color, or more specifically, how to register who's touching it, how that might register in a competitive sequence. The films themselves are robust; they're not affected by moisture. So, is there a super soaker measuring stick, if you will, that could be applied? My favorite slide is this. Obviously, I'm alluding to imaging, how we can image with different activities, for different activities with different materials, from a beer can to fashion, from lighting and curtaining to kind of where we are today in terms of flat surfaces and tagging them in different ways. Light, light, light. And finally, these mats here are play mats, specifically for school children. And, you know, it's an interactive way of talking about school and neighborhoods, or the ubiquitous smartphone. What if we enliven this foam mat that you see here with actual light up elements? Again, and the robustness of it, the cost effectiveness of it, as we now know printed electronics to be, can be fascinating. This is who we are. My direct contact information is here. Our job is to reimagine materials and reimagine uses. And we have been very successful over the years in working in a vast variety of applications, as you saw at the very beginning. The challenges of integrating these technologies that the PrintoCent cluster represents is what we really see as a major future endeavor. We work currently with design groups in London around smart materials and smart electronics, and as I said, with a couple of the PrintoCent partners, and VTT is a primary supplier to Macon and Associates. Any questions, or I will end my presentation. And
yes, thank you, Peter. Yeah, please send in your questions through the Q&A box there, and we'll have a Q&A session at the end of this webinar session. Really want to pick up a phrase that you used there, Peter, third dimension to the product lines. I think that nicely defines, from a designer perspective, what you can do with all this printed electronics is you can add that third dimension. And as we have the slogan in Decochrom, elevate printed graphics to the age of interactivity. So Marcus, please tell us how Decochrom has been engaging the wider designer community. Peter is a pioneer. He always gets involved among the first, but how are we spreading the word to a wider community of designers?
Yes, thanks a lot, Jan-Mikael. First of all, also welcome from my side. My name is Marcus Lechfeld, and I'm at the Department of Architecture, Design, and Media Technology at Aalborg University. So you already hear I'm neither from a printed electronics side nor from a chemistry partner in this project. So I would call myself an interaction designer. So I'm pretty much on the design side, right? And for us, going into this project in the beginning, we had like very little understanding of what electrochromic systems are and how they would work and how you can actually build them in some way, right? So we really, first of all, we had to understand ourselves what it's working on. And from there on, we understood what will be the problems for designers to understand this, right? So it's imperative that you understand the technology. And I think Jan-Mikael can sing a song about this, how often Invisible would get questions about potential uses of electrochromism that are just technically not possible because the people behind it wouldn't understand or haven't understood the concept yet, right? So our main goal in this project is to really engage people and also make them understand how the technology works, show them examples. And I'm not going to show too many here, but we developed a lot of different examples, including it into wearables, including it into, for example, you already saw Jonas, some example in Jonas' presentation there. So we really try to also extend what we know and what maybe even stupid examples for now, but just to also make people aware of it. But the first thing, of course, for people to be able to sort of experiment or understand these things is the need for suited tools. Jonna already said this. It's really one of these minimal things that we need to do before anybody can deal with these things. We need to have them being able to actually explore the technology themselves, right? So we actually created a toolkit. On the one side, you see the Decochrom toolkit, which then also subsequently influenced the Invisible toolkit, which you can buy now commercially, which has very much similar contents. But for example, everything that is extra in the Decochrom toolkit would be commercially available as well. And we have links to everything on our GitHub page as well, if you want to, right? But having the hardware is just the first step, right? If you have the hardware, and you heard Yanni Mikael explained how the systems work, you need at least 2 electrodes to make it working, right? You also need to understand how can this actually be used in meaningful ways, right? And this not only means that you have to come up with ideas to work them through, but then you actually have to design the display. And this can, if you are like a first timer, pretty complicated for you, right? So we actually started with developing also the respective software toolkits to help designers. And so we started off, for example, with a simple Adobe Illustrator extension, which would help you to create automatic outlines, etc., or create borders for example, a laser cutter, or for a cutting machine in general, right? That you could use just to ensure that people understand what they need and what it will entail to do, right? Also, for example, a piece of software that automatically calculates whether the 2 electrodes that you intend to use are in balance, like really simple parts actually, right? But that are just really needed. So the Illustrator, you can, as you see, there's a GitHub link that you can already download. But we are also currently working towards a bigger tool that actually can work outside of whatever tool you would be using, right? Because I mean, Illustrator is maybe the industry leading in the printed industry or with designers, but it's still not like the only tool that people use, right? And we want to, of course, cater to as many people as possible. So we actually started building our own small tool that actually would allow you to take a complete design, select, for example, certain elements that would then be cut out. It would create the cutting parts, it would create the design files, etc. So you actually have a very comprehensive tool at hand, and this will be released later this year, that actually will allow you to take, for example, an existing graphic. You see the Smurf graphics, for example, right? And then select what you want to make interactive, right? So for example, especially for retrofitting, this can be a very nice element. But how do we actually, why do we do this? It's really about these enabling technologies, right? And it's also about documenting processes, right? It's about like making things like letting designers, or enabling designers to understand where they can go with this technology, right? And how it will work. We also created, for example, an idea challenge where we asked designers to send us in potential ideas that they had for their technology based on our learning materials. And we got things that we would have never thought about, like, for example, combining it with UV light and using as, in combination with electroluminescent light strings, for example, to create interactive art pieces, etc. Right? So there are many ways that we engage with the design communities, but the main thing are actually our workshops. So we organized so far 21 co-creation workshops where we would come into places and teach people how to use the technology, and actually then also allow them to design their own displays. So we actually had over 260 designers and design students taught already about these technologies. And the good thing is not so much that they learn about it, but also we learn, because they come up with crazy ideas, with crazy new potentials or use cases, but also with ways, like if you work with designers, you know, one of the first things that ever happened at one of our workshops was that one of the designers took out a bottle of glitter and threw it into the electrolyte, right? Just to see whether it would work. And unsurprisingly, we had to put in a bit more electrolyte so it wouldn't stick on the ink, but in general, it worked, right? And these are things that you might think about, but of course, this is an interesting approach, whether you can also, for example, add extra plastics in between the two electrochromic layers, right, inside these things. But these workshops really also help us redesign our own tools and understand where we need to add things. Unfortunately, of course, actually the last workshop was at one of PrintoCent's events. Actually, the last physical workshop was at Prinze last year in the end of January, unfortunately. But we also now have an online workshop. So if you're interested, for example, and see what this can do, we will probably start this again once we can get back to our university, which will hopefully be in March, and then we will start out sending materials, and then you can do these things. But we'll also have special offers if there is, for example, a company approaching us. For example, we did this for Volkswagen, Lego, and some other smaller companies. We would actually come with remade ideas of their designs. And for example, I already had scribbled down some ideas that we can do for you, Peter, and your Nerf toys that I think could be interesting. But we would go in there and show them some ideas to get the ball starting. And yeah, I already mentioned our last workshop at PrintoCent, which was really very successful. We had many participants. Maybe some of you even participated. I don't know. But what we did with these industry-driven workshops is that we actually would come with ideas. And I would quickly like to talk about the one that we did for Lego. Because while we did, of course, something for Lego Systems, which is the company that actually makes the bricks that everybody loves, the one that I'm going to, or the work that I'm going to talk about now is actually what we did for the Lego Foundation, which is their head foundation, which is more focused on altruistic areas. And originally we talked about, like, for example, developing like smaller stickers with electrochromic materials that Lego could use on, for example, Duplo bricks, etc. Right? But then the Lego Foundation actually quickly realized the potential, and they dragged us, not really dragged us, but they invited us to join a project that they are working on. I unfortunately can't say the name of what that is, but it's basically, the idea is to develop a low-cost version of the Lego system that can be, for example, brought to smaller to developing nations or to refugee camps, right? Especially in South America is one of the target areas, as well as India for them. And they were really interested in using this displays as alternatives to more expensive OLED displays or whatever else they are using in their really expensive learning material, in their learning kits, the Lego education kits. And recreating the same experience that, for example, here you can in Europe buy for like 350 euros or something like this for a single class, or like for one pupil, and actually bring this at an extreme low cost point into, for example, refugee camps. And we designed a learning activity where the kids would learn about for example, solar energy or wind energy, and the displays would be used as a measurement tool for the children after they were explained to it. You can actually see it here, right? This is a wind energy where the kids would build like a small, you see here, these are basically plastic versions of classic round hole fasteners that you might know from stapling paper together and using these metal clips that you can fold out. Some of you might even know it from creating animated stick figurines. I don't know, these jumping jack figurines that you maybe have built as a kid. And this is basically what the Lego Foundation developed here for this kit. And we actually made use of it, like added a very cheap 9-volt motor extra to it. And then you can use the energy created by the wind itself. There's no need for extra energy or whatever, right? And actually see, for example, what is the influence of removing some of these wings or blowing faster or lower and so forth, so that the children actually can understand and get an understanding of how wind energy works, right? And this was a very, we tested all of, we had 4 different elements there, and we tested them with 119 kits at Lego World last year. That was also just right before the pandemic hit. And the results are really, really promising, and we're going to go and continue this development once things are going back to normal, right? But this is just an example of how we actually engage and develop and co-design together with, for example, industry leaders or with designers to reach new levels for electrochromic materials. If this is interesting to you, maybe check out our social media presence and our website. And if you're interested in, for example, getting in touch and seeing what we can, or hearing from us what we can do for you, hopefully soon also in person again, please get in touch with me or us, whoever else. I think if you write to Yanni Mikael, he's more than happy to forward it to me as well. And yeah, thanks a lot for the opportunity to present our work here.
Thank you, Marcus. Really, really exciting to see how you're engaging the design community. Excellent. Next up, if Marcus, you stop sharing, I believe Ashley will continue a little bit in terms of what has been achieved in the project thus far, and presenting some of the cases, some of the demonstrators that are emerging. Obviously, not everything is yet available for public viewing, so we've had to choose from those that we dare present at this point. But Ashley, the floor is yours, and do tell us about the vote as well.
Okay, yes, thank you, Yanni Mikael. Yeah, so as said, I'll give some insights to some of the prototypes that we've developed so far in the project. So they come in the scope of the prototypes that we've developed. We try to cover as broad a possible range of different application areas. So here, beginning with sports equipment and hand tools, but also I'll show some ideas that we've had around wearables, furniture, and these kind of things. So we're really trying to push the limits and find what electrochromics could do. So here's some examples. So first, a tennis racket. So integrating an electrochromic display into a tennis racket. So I think smart sports equipment is already becoming established, but most of them have a wireless link to a smartphone. So here the idea that perhaps the athlete could see directly after they'd done a serve, they could get some data directly from the sports equipment itself about how well they'd done. In particular, the benefits of electrochromic displays for this kind of application are really the robustness and flexibility in terms of fitting to some curved surfaces. That's demonstrated further by the axe prototype on the right-hand side. So we took one of the most basic human tools, an axe, and we thought, how can this become smart? So here you can see really the amount of curvature that we've managed to fit with the display. So it really fits into the design of the product there. And this has electronics inside it, so some different applications. So perhaps it could measure how many hits you've done, or give some information on the ergonomic performance. So whether the person using the hand tool is hitting ergonomically, or are they doing some damage to their to themselves when they hit. Moving on, one household equipment demonstrator built by one of our project partners, ThinkK. So this is a combined kitchen scales timer. So ThinkK are building this kind of high-end kitchen equipment using a lot of wooden materials and so on. So here, this kitchen scales timer, you can see the whole upper surface of it, which is around a A4 letter paper size, is this display, which indicates the mode of the device. So is it in scales mode, or if you lift it up, it turns into a timer mode. So this is interesting, both from the size of the display and also that it starts to give this feeling that the whole surface is interactive. So this isn't really a display embedded into a surface. This is where the whole surface itself is an interactive surface. So this is interesting direction. Next, a thermos flask, which indicates whether the contents of the flask is hot or cold. So, you know, this classic question, how does the flask know whether it's hot or cold? So here we managed to embed all the functionality, the display and the sensing electronics and so on into the cap of the thermos flask itself. One interesting next step with this, we're considering whether we could actually use thermal energy to power the display, so we wouldn't need to have any batteries here. Perhaps the thermal energy through Peltier elements or something could be enough to switch the display between the hot and cold sense. Here looking at, again, examples where we're using the flexibility and robustness of the display. So here fitting a display to a running shoe, and you can see the display is fitted to the curved surface of the toe area of the running shoe. So I think this kind of application, there are perhaps very few other display technologies that could achieve this, so this kind of flexibility. And here, for example, it could show how many steps the runner's done, but also information on this pronation, whether the runner's landing on the left or right of their foot or heel or toe or something like that. And again, rather than seeing it in a mobile application, they could see it directly in situ in their shoes. We took this one step further towards a more aesthetic integrated example. So on the top right, you can see a short video running. So here the display was integrated into a fashion boot, which we actually designed and built from scratch. So rather than just sticking it onto an existing product, which is then linked to a heart rate monitor that the shoe wearer is wearing, and above a certain heart rate, the display switches, so these flames are visible. So this would be a little bit of daily motivation to the wearer. So if you run up the stairs, then you see these flames appear on your shoes. This kind of small motivation effects. Inspired by the COVID virus and wearing of face masks, so we've also explored integrating electrochromic displays into face masks. So here showing something of the wearer's expression. So this visibility of the wearer's expression is somehow lost when the face mask is there. So we explored the potential for this as a use case. Also more with wearables, we looked at integrating the displays into a cocktail or work dress somehow, both looking at the back panel and also the neckline of the display. So whether we could adapt the outlook of the dress depending on different wearing contexts. So for example, during daytime, in the office, the panels could be obscured, but then perhaps for evening wear, then they could become transparent. So these kind of approaches. Another wearable which we've done more recently is this jacket, which is battery free, and it uses NFC harvesting from a smartphone to change the display state. So there are no batteries involved, and there's a NFC antenna in each of the left and right pockets of the jacket, which then there are two displays, and it turns one of them on or off depending which pocket you put it in. Hopefully there's a video that's going to play. Yeah. So when I click the button, it'll play. Mute the audio and perhaps skip ahead a little bit to focus on the changing aspect. So here, when there you see the NFC harvesting in the inside of the pocket, which is positioned to align with a smartphone when it's connected in. So this is this application case. So because it really takes very, very small energy to switch the displays. Okay. Yes, then as Yanni Mikhail hinted at the beginning, one of the targets that we have in Decochrom is to try and launch a crowd-funded proof of concept product. So the idea to include this in the project is really to show that we can really develop things as far as being a commercial or semi-commercial, however you judge crowdfunding things, product. So we've, of course, developed many different types of prototypes so far during the project, and now we have to try and focus on what would be really interesting to make as this crowd-funded proof of concept. So what I'm going to present now are really the loose directions that we're thinking to head in. So these things, although they sound quite specific here and perhaps a little bit trivial, these are really sort of general directions that we're going to go into, that we're thinking to go into. And what we'd ask you to do is to think about these kind of concepts and think which kind of these directions might be the most interesting or might be the most revealing or useful in terms of demonstrating what this technology can do. And we're going to ask you to vote in a online survey. So I think now, Petteri, you could share that on the screen. So hopefully that should pop up on the screen. There we are. I think we can move it out of the way. Yep, and I'll show a little bit more detail on each of these ideas. So the first idea area is around sitting or sitting indicator. So here, of course, everybody knows that with our working in the office, we're really sitting too much. So is the possibility that we could sense how much we're sitting and use an electrochromic to display that perhaps in the desktop or in a display that's attached to the desktop. Related to this, one of the project partners we productize, who I think will shortly present later in the session today, they have an activity balance board which you can use with a standing desk. So that could be something else that we could show in the desktop. Then again, related to the COVID pandemic, there could also be possibility that in tabletops, we could display when a table or chair has been recently occupied. In which case, when you come into a restaurant and you're choosing where to sit, you could choose to sit at a table which hasn't been recently occupied and is clean. These kind of ideas. So this is the first general direction that we're thinking about proceeding in. Secondly, this seems a little bit trivial example, but at least in our house, it seems to be quite critical. A dishwasher clean dirty indicator. So to know are the things inside the dishwasher clean or dirty. Shown at the bottom there is one early prototype that we made of this. So with a glass showing that it's dirty and then clean. So this is a functional prototype. And in the prototype, we activate it. So it's manually activated by turning the device, the display 180 degrees, this kind of idea. How we're thinking to maybe go ahead with this is that we could also include some energy harvesting in it. So for example, you could kind of shake the device to put it in one state or another. So that's this second case, which of course could also work with any other use case where you need to indicate two different states. So applications other than dishwashers. Then a third case is this dog activity indicator. So as you see from the top right there, this is something which Invisible have already prototyped. So it seems there's some interest in this, but is this something that we could take further in the Decochrom project? So other use cases being, of course, human activity or some kind of object motion indication. That's the third case. And then for the fourth case, In one of the workshops which Marcus introduced, and as Marcus said, the workshop attendees came up with all kinds of crazy ideas that we could never think of ourselves. One of the prototypes, which is shown there in the left, was this shaking indicator. So if you buy some perhaps premium fruit juice and it says shake the bottle, it might be nice to have some interactive indication of when you've shaken it enough that you can really get the full appreciate the juice. So this was one prototype that was built in one of those workshops. So somehow going forward from that, could there be some possibility, some use cases where we could make this kind of bottle shaking indicator? Of course, there might be industrial cases like paint shaking, when you have to shake a spray can for 2 minutes or so on, or chemical or medical industry. So there might be some home medicines which need to be shaken for a certain time before they're functional. So this kind of idea. So I think this is again something that we could put together, and hopefully could be utilize energy harvesting. So those are the 4 examples. So hopefully that would give you something to think about, just as a start point. And the survey is there now, visible in your screen. So would be interesting if you could vote which of these you think might be the most interesting direction, and we'll come back and review that at the end. Okay, so that's the end of what I was planning to present. Yanni Mikael.
Yes, thank you, Ashley. And we have roughly 50%, so half of you in the audience have voted. The speakers and I, as the host, do not have a vote. So do get your votes in. And as Ashley was indicating, the idea is to take the concept that receives the most votes and consider if it might be viable for a crowdfunding campaign or other similar paths of getting it into market. All right, excellent. So we've now learned a little bit about the project, how the design community has been engaged. The beauty of this project, of course, is that in addition to engaging the design community, getting these wild ideas, presenting them the tools, we also have the technical developments in terms of new materials, taking them into demonstrators. Now we have a few of the project members presenting themselves briefly, and we begin with our very own Invisible. Carlos Pinheiro, the CTO of Invisible, the floor is yours.
Thank you, Yanni. Thank you for the opportunity to share my excitement and also the chance to present you what is the state of the art in printed electrochromics. Very briefly, what is Invisible doing and offering to the customers, but also to the partners. As you see in this demonstration, printed intelligence and electronic intelligence is more and more spread in our daily environment and routines. And our main goal at Invisible is to create a visual indicator technology that will enable electronics to communicate effectively with humans using very simple and easy to read interface. And what we are exploiting is the ability of color change electrochromic materials printed in patterns that will allow an universal way of communicating bytes of information that are being monitored by electronics, and users actually, and humans can actually read it. The companies today, almost 30 employees. We are located in 3 main operation units in Europe. And we, at the moment, we still cover the entire value chain of electrochromics, from development of new electrochromic materials, something we do here in the Ink Center in Germany, but we also developed the production processes into sheet-to-sheet format and also in roll-to-roll format. The sheet-to-sheet is based in our pilot production in Portugal, where we have our customer center. We support prototyping ideas and visions to our customers, and the roll-to-roll production in our operations in Sweden, in Linköping, where we have capacity to produce millions of printed electrochromic displays. We have also inline quality control of every single display we print in that line, but also we have expertise and capability to print other printed electronic components and modules. Our interests and our participation in Decochrom has been to bring knowledge about electrochromics, also providing the vision to which features we need to improve in order to increase the portfolio of potential applications we can go with this technology. But the most rewarding activity was actually to transfer this knowledge to non-technology or non-chemists, non-printers community, and see how they got so excited and they themselves started to improve the technology themselves and propose back to us other means to create and produce these technologies for the prototyping level. And I must say that I have to say thank you for the partners to be so engaged in this project. Thank you for the European Commission to have sponsored this project. It has been personally very rewarding to see how these designers have actually made our role in this evangelization of the technology. We are quite obsolete because they pick up and they are themselves doing it. So they come up with all these nice applications we have seen in the previous presentations. Here are just a few more examples of it. But also they have improved the processes to make these electrochromic prototypes. And they are themselves disseminating to other designers and other communities how to exploit and to produce their own electrochromic displays. And so what we have learned from this experience and this interaction with our partners in Decochrom has improved our own offering, and we have on sale our own electrochromic ink set, and we already have ideas on how to improve, create the new generation of this ink kit based on the feedback we got from our partners in Decochrom. So what I'm here, the message I'm here to present to you as well is that we have everything you need to get ready with electrochromics. Be it if you want to do your own prototypes in your own garage, we can supply you with the materials. We are creating also the design tools, as Marcus already showed to you. It's still not yet fully developed, but we want to make it easy for you to work with electrochromics and create your own electrochromic projects. And as we go into more product and commercialization, we have the prototyping and consulting services, as well as the manufacturing capability to support you to launch your electrochromic products. And so again, thank you for this opportunity, and thank you to all the partners at Decochrom and Lapland University for coordinating this very exciting and rewarding initiative.
Thank you, Carlos. I'm not going to comment since I'm an insider. Next up is Claudia Costa from Sonae Industria Group's Surforma. Claudia, are you on the line? Yes.
Yes, I'm here. Just let me start my video. You can hear me, right?
Yes.
And hear my presentation. Okay,
Yes,
so
you can see.
first of all, thank you so much for the invitation. It is always a pleasure talking about Surforma and also about Decochrom, which is a project that I really like a lot. So here today, I will take the chance to talk a little bit about Surforma, and then also what we are doing inside Decochrom and why. So first, a quick group overview. So we have been created in 1959, so a couple of years ago. as you can see. And during the first years, Sona Industria, which is the group now, really grows a lot worldwide, creating and buying industries, mostly in the wood panel businesses, and also production of resins. And quite recently, in 2016, the group was reformulated, and they created, or they did a joint venture with a South American company called Arauco. And because of that, we had to create an R&D department dedicated to Sona Indústria de Revestimentos, which was the name of the company that was producing HPL products at that time. And then in 2018, we created Surforma brand, which last year became the name of the company. So since 2016, in terms of production, nothing changed. We just changed the name, if you want. Okay, so just to show you the dimension of Sona Industria, this is really a quite big group. As I said, we have a worldwide presence with many different business, such as laminates and components, which we, Surforma, is present, but also in board business all over the world, but at 100% in Tafisa, Canada, and 50% in Europe and South Africa, but also in other businesses like real estates and things like that. So, Surforma, you might now wonder what we do. So, as I said, we are HPL producers, and an HPL, it's a construction material made of paper and resin, as you can see in this image. So we have several types of different papers, impregnated with different type of resins. All of them are stacked together and pressed at high pressure and temperature to give a uniform and unique composite, let's call it like that, that you can then use in several applications like furniture, interior decoration, design, architecture, and things like that, as you can see in those pictures. I would add also the huge world of transportation industry, like trains, planes, buses, cars, anything you want. And why is this so interesting to try to add some interactivity to these products? Well, I believe when you look at this kind of image, it became quite obvious. So okay, I can agree that it has a very nice aspect. It is good looking, very trendy, very nice, but then there is no interaction. That's it. So it doesn't change. It doesn't show you, it doesn't interact with you, it doesn't help you to change your moods, it doesn't show you the way, it doesn't do anything really, it's just there, right? So this is why at Surforma we have take a deep look into the mega trends in the future, and we have divided or separated our projects into several trends. So we took these mega trends and then we have incorporated them in our R&D department. So nowadays, all our projects really fit into these Surforma trends. Well, I will not go to all of them, but in Decochrom, for example, and other projects, we are at Surforma Tech, and we really want to contribute to this area of integrated electronics using harvesting systems, why not, interactive products, but mostly creating interactive products with the capacity of recognition of signs and stimulus, okay? So, Decochrom. I have put it here the way we do it. but I would like you to show you more than this, or to help you understand more than this, which is, let me just remove this out. Okay. Which is, I would like you to understand the beauty of this, because we are not integrating electrochromic devices into HPL. We are creating electrochromic HPL, which is something quite different, because if you know anything about electrochromic devices, by this scheme, you might understand that the paper, that white sheet of paper that you can see here, I don't know if you can see my mouth. You can see that one sheet of paper became really the electrochromic device. So we transform one sheet of paper into 2 electrodes and 1 electrolyte at the same time. And then this sheet of paper with the silver tracks, with the printed functional materials, that is then impregnated, and this impregnation acts as the electrolyte, if you want. Then we have to integrate the interconnectors, if any. Sometimes you don't need none. And then we assemble everything. Remember the figure I showed in the beginning? So this second sheet of paper here is now this white one that we could put in here, and then we press everything. And at the end, you really have an HPL which have electrochromic behavior, right? So where do we see this? Well, anywhere we can have, where we can find HPL in the first place. So everything which is furniture, everything which is design, in architecture, furniture, I said furniture already, yes, transportation industry, and so on. So yeah, I think we are doing really great things in this project, and I hope in the near future we can have more interactive homes in terms of walls and furnitures and stuff like that. Thank you.
Thank you, Claudia, and really, really exciting work. As Peter said in his talk, also manufacturability. There's been a lot of advances in the past few years, and it's great to see that it's even taking a step further into being really integrated into the final products. Next presentation is from, if Claudia, you can stop sharing your screen. Just to mention, Invisible and Surforma are PrintoCent members. Next company we productize. Antonio has been working with the PrintoCent community for many years in different forms. We Productize has also been a member, and very hands-on product development. Antonio?
Hi.
Yes.
Good morning. Good morning, or good afternoon, or good evening, depending where you are. Well, I'm trying to share my. Let me just see. I'm not finding. Okay, yeah. Okay, so I'll thank you for the opportunity. First of all, I'll talk about applications in one of the products we have. It's in a brand that we have, Body Mover, where we produce and commercialize standing desks, balance boards, sit-to-stand desks, and we like to bring some motivation effects, interactivity to the users. So it's all about bringing more movement, energy, and joy to your work life. And as many of you, since this pandemic, we work more from home. So we are selling more the standing desks and balance boards. And at our boards, we have two types. One brings more movement than the other. We decided to integrate some standing indicator, some physical activity indicator that could, if you step on it, I'll show some video. It changed from a sad face to a happy face. But we had some feedback from the customers that it's not so handy to look down to the board. So we are now in the next phase that we are developing a new concept, so the user can place it wherever they would like. So if it is in the board, you can place it, well, in any place they want. At the moment, it is in a fixed position. If it is in the standing desk, we have a tabletop converter that you can put in your desk. You can place it on the top, in the middle, wherever it's more handy for you. We have also a sit to stand desk, and again, you can place it wherever it's more feasible. So very briefly, this is just another application of electrochromic that that we are developing at the moment. Thank you very much.
All right, thank you, Antonio. That was a quick presentation. Thanks.
Yeah, very quick.
Sharing also the experience, and it's exciting that you have actually applied it to a product and tested it in the market, and now working off of the feedback. I do encourage everyone to visit Body Mover. We tend to sit too much, so do prop up your working position, and Body Mover is one way to do it. All right, thank you, Antonio. Next up, we get a little bit of perspective from one of the leading research institutes in electrochromics. Antonio, if you can stop sharing your screen.
I will.
So Marco, are you? Yes, there you are, Marco. Marco Schatz from Fraunhofer will share their work, Fraunhofer's work in the space.
Yes, hello. Thank you for the introduction, Yanni, and thanks for the opportunity to present a little bit from our work, from the research community in the field of electrochromics. I'm the expert group manager here at the Fraunhofer ISC in Würzburg, Northern Bavaria. And we are a classical materials research institute working on different topics. And our electrochromics group is part of a larger department. It's called the Fraunhofer R&D Center for Electromobility. So we work here on classical lithium-ion technologies. And if you look at the electrochromic film, you will see a lot of similarities between both technologies. So we were embedded here in a larger department, small group working on organic, inorganic, mostly organic, inorganic electrochromic thin films. We look more from the applied research to the process development, looking into a large-scale processing, mainly roll-to-roll processing, and also with a strong focus also on the cost efficiency of the materials and the process itself. We are a department of more than 40 employees in the meantime, large annual budget, have a lot of national, international collaborations, mainly with here battery manufacturers, chemical companies, and OEMs. And talking about electrochromics, the electrochromic technology here at Fraunhofer ISC, we have in the meantime more than 50 years track record in developing electrochromic materials and devices. You see here on the right side a few projects. We were involved in the last years in a lot of large projects, national, European projects, as well as contract research doing for industrial partners. So we have a quite extended network of research partners all over Europe. we work from the synthesis of the materials over the processing up to the device assembly. And in the meantime, we generated a good pattern portfolio from the materials of the cell configurations up to the electrolytes, and also accompanied always with scientific publications. And why still a research needed on electrochromics? So our focus and our unique selling points, how I could call it, is we develop novel electrochromic materials and devices. We focus on roll-to-roll processing, and we have a strong portfolio in situ, in operando characterization methods, which is also important for supporting the industry and the companies to bring the electrochromic systems forward. And here a few insights on what we are really doing. Here you see a batch process where we come from the past, making large area electrochromic films on glass. Here a example of a dip coating process. So with our materials, we are quite flexible in design and chemistry, and we look always in the scalability and cost efficiency of the materials. And it goes more and more towards roll-to-roll processing to reduce the production costs. You see here one example of our roll-to-roll line where we make these electrochromic thin film electrodes. This is a previous project called ELICON. Here we scaled up the production of electrochromic films in Europe. Also here in this consortium, Invisible, for example, was involved. So there is a strong connection with the companies involved in electrochromics since a few years. And here's another example about smart window applications, which Yanni showed at the beginning, which is one of the biggest markets and one of the oldest electrochromic products. And here also we are involved in a European project, in an ongoing European project. Here we combine different technologies. Here is one example combining electrochromics with thermochromic glazing materials, all about energy efficient buildings, which is a main focus for the future developments also in our institute. But we are also happy to look on applications beyond smart windows. This was more from the past, and now we are looking also together with companies like Invisible a little bit more into the future, where electrochromic materials can play a role. And we heard a nice introduction to the project. So our focus here is a little bit on the material side. Here we are involved in work package 1, production, scale up of electrochromic inks, processing electrochromic surfaces, and then enabling system components integration, all to come to new designs and new pilots. And here are some highlights I want to share. This is non-confidential. Here what we are doing as a research institute, why we have I think also a key role here from the value chain, from the beginning of the value chain. We really work on the preparation here on electrochromic inks. Here's one example of a blue electrochromic polymer ink with a high bright state transmittance and in a deep blue colored dark state. Then we also look on other materials, interesting materials. One example here is organometallic polymers, electrochromic polymer inks, which showing here, for example, a blue and a red color change, and then all goes to the direction of at the end to a neutral colored electrochromic material or electrochromic system. So also here in Decochrom, from the material side, we look from the classical blue electrochromic materials towards other color variations. And here you see then in work package 2 and 3 some examples where it will then go when we are talking about large area processing, large scale processing. Here are the examples from the project where we could really show and demonstrate the first large-scale row-to-row processings of various electrochromic materials here on a certain scale. And then we developed also a first generation completely row-to-row fabricated electrochromic film, showing a very high optical contrast, which is which is very important for these, also for the display applications, to see the color change immediately when you power it. And then also a side aspect of our work is looking on different designs together with the other partners in the consortium. Here's one example where we did some segmented electrochromic films where we could independently switch the different segments. So that was a short overview of our work. And yeah, thanks for the opportunity. And here are our contacts. If you have some questions about research where we are involved, you can contact us afterwards. Thank you.
Thank you, Marco. Yes, and then last but not least, we have Thomas from VTT. VTT being one of the founders of the PrintoCent community, and with a wide range of different capabilities. I'm sure Thomas could speak for hours, but let's keep it to 5 minutes.
Great. Yeah, thank you very much, Yanni Mikael. You're right. I probably could speak for hours on this topic, but today we're going to highlight some of the exciting activities that we've done in the Decochrom EU project. And I really want to point out that this project was really about these electrochromic visualizations and this, like Yanni Mikael said, this age of interactivity. And in this project, we're really driven by design. So I'm a senior scientist at VTT in Oulu. Please contact me if you have any questions later on. At VTT, we specialize in flexible and printed electronics, and that's our role in this project as well. We can do work from material tailoring and inks to manufacturing components, and all the way up to system integration. And I'm preaching to the choir here. You all know quite a bit about what our capabilities are, but we really are a unique research infrastructure in Oulu with all these capabilities under one roof and a global reach and over 20 years of experience. We're printing components like organic photovoltaics and batteries. We do roll-to-roll integration of printed and traditional electronics called hybrid electronics. And in that case, we're also incorporating various sensors and making systems. And we even do a lot of post-processing as well, which you're familiar with, the injection overmolding, lamination, laser cutting, and so on. Now today, like I said, this is a quick speech about the Decochrom project and how we're able to bring life to these electrochromic visual indicators. In the project, I'm the work package 3 leader, but also involved in some of the other work programs. But today I want to focus on these 2 case studies that have been developed within the work package 3, in which we're able to augment the TRL levels for the fabrication of these systems. One is called Sensis. It's this electrochromic fish embedded in polyurethane, and the other is an activity badge. So if you like that dog activity badge, we're ready to go with making thousands of units if you vote for that. Don't take my word for it though. The Sensis fish, this is a multi-sensor hybrid system where we're able to use various printed sensors and an NFC antenna. And with this system, you can actually toggle between different inputs with a capacitive touch sensor. And you can choose an input from the NFC antenna, a temperature sensor, or a force sensor. And there's also a room for a plug-in power source as well as a battery. And what I want to emphasize here is this idea of a design pull, not a technology push. Here I asked the designers, let's come up with something fun and creative. So on the left-hand side, you see this fish that they drew. They said, let's have a few little sensors and inputs and a visual indicator in the shape of the fish fins or scales. And this is great. So we got the electronics people involved from both VTT and Invisible. And we came up with the design, we made the products, and then we've tested them. So quite fun use cases, and we've learned a lot in the process. Another use case is that activity badge. This was done earlier on in the project, where we've done roll-to-roll printing and of the conductive lines, as well as the electrochromic displays, and we did hybrid integration, and then we came out with a project. There's a nice publication here in the Journal of the Electron Device Society, if you want to take a look at that. Another aspect, there's like Yanni Mikael said, I could probably talk for hours about this, but one thing that has been quite interesting at VTT lately is we have these roll-to-roll lasers. One is our CO2 laser on the delta converting line on the left-hand side. The other is our UV laser. They both have their advantages. One really nice thing with the UV laser is very fine precision, and this is what we are actually able to achieve. You can even finally cut through polymer films without cutting through the back plane, and you can really get nice fine features. So I recommend you take a look at these two publications here if you have time. And we're also doing work not in Decochrom but with wearables, and this is a double-sided wearable on polyurethane that was all done in a roll-to-roll process, and we're able to print, cut the vias, and then have this nice product, which you can see on that the figure there. But at VTT, we're ready to set a course for the designs of the future, and at VTT we are going beyond the obvious to ensure that the technology solutions will exceed your needs. So I do encourage you to contact me or anybody at VTT in the printed intelligence domain. But on that note, it's quite cold up here in northern Finland, but it is beautiful. Thank you very much.
Thank you, Thomas. Yes. All right. Before we let people go outdoors and take a break, I know we've been sitting here for a while. Exciting moment approaching. Thomas, yes, thanks. So looking at our agenda, we are now approaching the end. It's nice to see how the audience has stayed well, because I guess this is what most of have been waiting for, is to see the results of the poll. And this is the first time any of us are seeing it, so it should be displaying in all your screens. It says that the winner clearly is the sitting history indicator. I don't know if you were tired of sitting for an hour, over an hour and a half, and listening to these talks, but certainly this is something that we all know can be a problem in these modern times when we're sitting all day at our computers. So in the Decochrom project, we will be looking into this topic and see what we could do to advance that concept even further for your benefit and our benefit. All right, thank you. So now we are already running a little bit over time, but there were a few questions that were sent during the talks. I'd like to invite all of the speakers to share your videos if you're in a presentable mode. I'd like to highlight some of the questions there that have been brought up and addressed. All right. There's Portuguese coming from someone's. All right. Obviously, one question in all of this, what we're doing, is the environmental impacts and sustainability. Who would like to first tackle this question? I can say that in the project, this topic is a big topic.
Não gostei.
We have a...
Sorry, it's my kid.
Yeah, you didn't like something. We have partner Vertec helping manage the LCA process. So we're doing life cycle assessment of what we're doing here. And certainly a lot of the demonstrators that you saw there still have a lot of the breadboard electronics, basic electronics, but the premise is that we use as sustainable materials as possible when we scale these and optimize to production. I'm putting everyone on the spot right now. Who wants to add?
I can add something.
Yes.
Actually, it's okay. Don't worry about it. No.
Come on, Thomas.
I mean,
Well,
this sustainability question, of course, has different perspectives, and you know, Yanni, we are facing that question multiple times with our customers, and we learned that the sustainability, it's not the question doesn't have the same definition according to the final application and the customer. So I would say that to seriously assess sustainability in the long term, that's something that goes beyond this project. What we are doing that will contribute to that is actually looking to the production of these technologies, printed electrochromics, from an LCA perspective. We are not yet improving our reduction of our footprint, but we are identifying where are the critical steps that are dealing to potential conflict with sustainability in the long term. So that's something that our LCA partner is doing in the Decochrom project. And at the same time, we have also developed the production process for these new materials. Something we didn't really talk today is that we are developing new colors. Professor Davide Bonifazi group from Vienna University is working intensively on developing new colors. We have a nice purple color, red color, but also more recently he showed us a prototype of a black electrochromic color. And we are also looking to scale the production of these new polymers. So it's not just a matter to find these new chemistries, but also if we want to create business out of it, we need to find resources and availability of these polymers. And so in looking into the production into larger scale, we are also assessing the LCA of that process as well. So what I can say is that the contribution we're doing in the project is to identify where are the red flags in the process. And hopefully we can then properly assess and have strategies to try to come up with solutions to turn those red flags into green flags.
I would also make a comment that in our case, what we find is sustainability is the larger topic. We really try to drill down. Are we talking about biodegradability? Are we talking about recycling? Or are we talking about renewable resource? And so what we end up finding is it's a combination thereof. I would say that our clients generally are interested in either biodegradability or renewable resource. Recyclability within a lot of the configurations of the products we work in are problematic worldwide. Anyway, that's just our experience.
And Yanni, I just want to mention what I was going to say, because within the project, we actually have a partner, University of Strasbourg, looking at ITO-free electrodes. So that's one aspect of the LCA of a lot of these electronics that needs to be reduced, is some of these critical raw materials usage. And that's something that's been done within Decochrom, but also has a larger impact in this printed electronics domain. The sustainability of the materials we use is a very interesting topic, I think.
And then certainly also the impacts of the applications themselves in terms of health, safety, and living more sustainably as well. So the impacts of using these technologies can have lots of advantages. And the trend of electronics being embedded into pretty much everything is very real. So where there are those power sources, electronics already in them, this is certainly a very low power consuming and comparatively sustainable display technology. All right. There have also been questions relating to the manufacturing process. One of those is it only roll to roll? By the way, hats off to RISE in Sweden, being one of the foremost research institutes in roll to roll printing. We saw that Fraunhofer is working also in roll format. VTT has lots of roll facilities. But are there other than, can we use other than roll-to-roll printing techniques? Carlos, I guess you can answer that.
Sure. That's a bit weird, actually, Yanni, but you know the answer already. Let's play this role. Yes, of course, we do mention sheet-to-sheet production. But I would say that in Decochrom, Marcos and Walter, for example, they have to create their own means to do production of electrochromic displays using a desktop inkjet. So I know Walter has been spending a lot of time hacking commercial desktop inkjet printers that you can buy or do you have at home and adapt it to print electrochromic films. So that's the versatility of this technology, that you can use it whatever you want almost, and very soon we hope we can also bring publicly a new kit that we are developing that it make it even easier for anyone to play with electrochromics and prototype their own display electrochromics. So I would say that yeah, the ways to get prototype level electrochromics, it's large, it's enormous.
All right. I guess we've covered, there were a few other questions, but many of them linked to what was already asked here. I would like to mention most of the Decochrom project partners have already appeared here or have been mentioned, but I do want to still highlight that that COC is a partner, New University of Lisbon as well, and Lighting Design Collective. So I trust that now all of the partners have been checked off the list. It continues to be a very exciting project. We have a lot of fun doing it. We're thankful to the European Commission for funding this initiative. We're thankful to PrintoCent for helping put us all together in the beginning of the project and giving us this stage to talk about what we're doing. I hope that this triggered a lot of interest in what we're doing. Feel free to approach all of the speakers here, decochrom.com, PrintoCent.net. And let me share my screen one more time. As for the PrintoCent webinar series, to end things off, more to come. We have 3 more sessions this winter. Next one is already a week from now, looking at new horizons of antennas. Sign up is already available. Go to PrintoCent.net, the events page, and you can sign up for that. Also, we'll have a session on rapid diagnostics, and another EU program called EU Smarties will have a chance to present their success stories March 16th. If you missed the previous sessions, those are now available for viewing on YouTube. And as mentioned earlier, this session as well will be available for viewing and sharing. Please spread the word, spread the love. We strongly believe printed electrochromics will be a leading interface display when intelligence is already all around us. We are elevating printing to the age of interactivity. Thank you all for viewing. Thank you to the speakers. Any questions on PrintoCent? Here are the contacts. All right, I need to go. There's a call coming in. So thank you all. Take care. Stay safe.
Bye-bye.
Thank you.
Bye-bye. Thank you.
Care all.
Kiitos. Hey, hey.